Today we're going to continue with the lesson 4 notes. And after yesterday, you should have all completed the unit circle. Hopefully you noticed some sort of pattern between the unit circle. I know this year you're not going to have to memorize all of these values, but in the past you have, and most likely in the future you will have to. So there are a few tricks to memorizing this. Everyone kind of develops their own different pattern, but I always go by the fact that the angles are multiples of each other. So I kind of just draw lines across my coordinate plane. So for example, at 30 degrees, I'm going to draw a line straight across, which is at 210. So if you notice, both of these angles are at pi over 6 or at 7 pi over 6. And also they have the same ordered pair for their x and y values. It's just the signs that differ. And I notice I'm missing a negative sign there. Okay, so you can do that for all of them. I could highlight across 45. That's the same as 225. I can highlight across 60, which is the same as 240. Okay. And then I can recognize that this pattern also reflects into quadrant 2 and quadrant 4. So 120 and 300 are the same as 60 and 240. 135 and 315 is the same thing as 45 and 225. And 150 and 330 is the same as 30 and 210. So you can figure out your own pattern. That's the pattern that I use. So I just memorize the first 3 points and then I keep reflecting them around the unit circle. Moving on to the next set of examples. The directions here say to find the exact value of the 6 trig functions given the angle. If not defined, write undefined. So remember that you can have angles that are on the coordinate plane, but you can have angles that are larger than 360, and in that case you just have to match them with what the correct angle is on the coordinate plane. Number 1 is 2 pi over 3. So if we scroll up to the unit circle, and we locate where 2 pi over 3 is, we're going to see that 2 pi over 3 is located right here. So 2 pi over 3 corresponds with a negative 1/2, comma, square root of 3 over 2. So recall that when you have your ordered pair, this is your x value and that is your y value. So first number is x, second number is y. Also recall that your x value is always your cosine value and your y value is your sine value. So if I start listing my 6 trig functions, we're going to start with sine of 2 pi over 3. Sine is equal to y, and it's technically y over r, but because it's the unit circle, r is 1. So this is equal to your y value, which is the square root of 3 over 2. Next, we're going to do our cosine value. Cosine of 2 pi over 3 is technically x over r. R is equal to 1, so just our x value is negative 1/2. We have tangent of 2 pi over 3. Tangent is y over x. Y over x gives us square root of 3 over 2 divided by negative 1/2, which is the same thing as multiplying by the reciprocal. So we have the square root of 3 over 2 times negative 2 over 1. And from here we can cancel our numerator and denominator of 2. Multiply straight across, we have negative square root of 3 over 1, or just negative square root of 3. Next we have cosecant. Cosecant of 2 pi over 3 will be found by r over y. Because r is 1, we can just say 1 over y, which is 1 divided by the square root of 3 over 2. When we multiply by the reciprocal, that becomes 1 over 1 times 2 over the square root of 3, which just simplifies to 2 divided by the square root of 3. However, you cannot have a radical in your denominator, so we're going to multiply both the top and bottom by the square root of 3. This gives us our solution of 2 times the square root of 3 divided by the square root of 9, which simplifies to 3. Remember that sine is paired with cosecant, and the next one that we're going to do is called secant, which is paired with cosine. They are found by the opposite values. Secant is 1 over x. 1 over x gives us 1 over negative 1/2, which when you multiply by the reciprocal, it's negative 2 over 1, or just negative 2. And recall that cotangent, which is the last value we're finding, is paired with tangent because it is also the opposite. So while tangent is y over x, cotangent is x over y. And x over y gives us negative 1/2 divided by the square root of 3 over 2. Negative 1/2 multiplied by 2 divided by the square root of 3. Your numerator and denominator of 2 cancel, leaving negative 1 over the square root of 3. We need to rationalize, so multiply the top and bottom by the square root of 3 for your final answer of negative square root of 3 over 3. And those are your 6 trig values. Okay, so the unit circle always tells you cosine and sine, and then from there you can find the remaining 4. Next, we're looking at 405, which is obviously larger than 360. So 405 is the equivalent of 360 plus 45 is equal to 405. So we're looking at the angle and the info paired with 45 degrees. 45 is paired with the square root of 2 over 2, comma, square root of 2 over 2. All right, so we're going to use our x and y value to find our 6 trig functions. And I'm actually just going to go through these without explaining. I think we've explained a lot how to find all 6 trig values. So just follow along as I write this out. Okay, and now that we finished that, I'd like you to try the on your own section by yourself. We've done a lot of these examples, so work on this on your own section. They're actually the same ones that are on your Go formative today. So do your best to answer the 6 trig functions for those. We have 5 pi over 2 and negative 45. I'll just give you a helpful hint there. That negative 45 is paired with 315. Okay, it goes in the negative direction. Okay, this next section on a typical school year is something that I have students do by themselves, but we're just going to go over it on the video because it's kind of hard to work in groups. So the directions say to use what you know about the unit circle to identify when each trig function is positive or negative. So next to each function, circle whether it would be positive or negative. So what I would typically tell students to do is to pick a point in quadrant 1, quadrant 2, 3, and 4, and then test them to see what your values come out as. So let's actually just scroll up to the examples that we just did. So when we just did number 1, I'm talking about number 1 up here, number 1 fell into quadrant 2. So take a look at the sign of all of your values. So in quadrant 2, your sine value will always be positive, your cosine value will always be negative, your tangent value is always going to be negative, your cosecant value is positive, secant is negative, and cotangent is negative. Number 2 is an angle that falls in quadrant 1. And every value, so all of the trig functions have a positive value in quadrant 1. So we just looked at what quadrant 1 and quadrant 2 would look like. So I'm just going to start in quadrant 1 and circle these. Your sine value for quadrant 1 is always going to be positive, cosine positive, tangent positive, cosecant, secant, and cotangent. All of those are positive. And what we determined with quadrant 2 was that your sine value is positive, but your cosine value is negative. And you can just think of this by thinking of this right here. If you know what all 6 trig functions are, you don't even need to test a point. Just think about your x and y value. Tangent is always going to be y over x. If y is positive and x is negative, your tangent value will simplify to negative. Cosecant is 1 over y. Your y value is positive. 1 over positive will be positive. Secant is 1 over x. X is negative, so secant will be negative. And cotangent is x over y, which is negative over positive or negative. So notice here that your sine and your cosecant, which we already know are paired together, those are the only values that will be positive. In quadrant 3, both your x and y value are negative. That tells us that your sine value is negative, your cosine value is negative, but tangent is y divided by x. If you have y divided by x and they're both negative values, a negative divided by a negative is a positive. Cosecant, negative. Secant, negative. Cotangent, also a negative divided by a negative, so that is positive. And quadrant 4, positive x, negative y. That means your sine value is negative, cosine is positive, tangent is negative, cosecant is negative, secant is positive, cotangent is negative. So here, your cosine and your secant sign are positive. All right, there's a saying that you'll notice if you look this up online. It's quite popular. It stands for starting in quadrant 1, working counterclockwise, but in the order of the numbers. So quadrant 1, all. Quadrant 2, students. Quadrant 3, take. Quadrant 4, calculus. And if we look at the letters, A for all, that means all values are positive. If we look at S for students, that tells us that our sine values, so anything that's related to sine, that would be sine and cosecant. For take in quadrant 3, that's telling you that your tangent values, so anything corresponding to tangent, tangent and cotangent, are positive. And lastly, calculus C for cosine. So the saying all students take calculus working counterclockwise around the coordinate plane tells you which functions are positive and where they are positive. So the reason why you need to know this is because you have to know the signs for every point on the unit circle. But also so you can read something like this next example set and determine where your angle is going to lie. So if we take a look at number one says that the sine value is less than 0. So that's specifically telling us that sine of theta is negative. And the second part says that cosine is also less than 0. So that's telling us that cosine of theta is negative. So in which quadrant is both your sine and cosine value negative? It's only going to happen in one quadrant, so you only have one answer. So where is sine and cosine both negative? And that would be in quadrant 3. The answer to this, name the quadrant in which the angle lies, quadrant 3. And number 2 says sine is greater than 0. That's telling you that sine is positive. And cosine is less than 0, telling you that cosine is negative. So where on the coordinate plane are you going to have a positive sine value and a negative cosine value? That's going to be in quadrant 2. Okay, and again, please try the on your own by yourselves. Also, the same 2 problems that are on your Go formative. Email me if you have any questions, and have a great day.